Could you take out your exercise 14.1 over? Exercise 14.1, any issues regarding question 3? Question 3? Yeah. You need to explain whether this curve has a stationary point. Okay. Then question 7. Question 8. Question 10. 10, okay. And 14. Okay. Alright, so let's look at question 3.
Please make your way to the hall now. Please make your way to the hall now. Thank you.
Okay, so when you differentiate, you should be able to get negative 7 over x minus 2 squared. Then in part 2, the question asks whether, to explain whether this curve has a stationary point or not. Okay, we know that in order for us to determine the stationary point, this expression itself needs to be able to equate to 0. Okay, when it equals to 0, I must be able to know a x value. But looking at this case, if I equate it to 0, clearly, okay, I will not be able to get an x value. So why is that so? Okay, the reason that is the case is because of this expression that's in the denominator. Okay, so we know that x minus 2 bracket square is always more than or equals to 0. Okay, yeah, it's always more than 0 in fact, because the question says x cannot be equals to 2 for all real values of x except x equals to 2. Therefore, your dy over dx, since the denominator is always positive, having a negative number in the numerator dividing by a positive number, dy over dx will always be less than 0. Okay, so it will never be able to equate to 0. Okay, so therefore we say that this curve does not have a stationary point. Okay? Sorry, give me a minute. Let me check. a problem because your answers for part I, you're getting k equals to -2 and k equals to -8. But then in the textbook answer behind, it says that k equals to -8 is not given. Is that the main issue? Okay, not about the solving process, right? Okay. My own solution, I've done it already. Okay, it's also I get two answers, -2 and -8. I don't see the reason why we need to reject away k equals to -8 lah. Okay, or will anyone have thought or input or any insights that why we should reject k equals -8? Because I don't see why we need to reject it. Yes. Yes. Okay. But of course, in the exam they wouldn't do it that way lah, because waste of marks. Okay, as a setting of exam point of view. Alright. Okay. So 10 part I, you should be getting k equals to -2, k equals to -8 in your solution. Okay. Then in part 2, right, you need to do it in two separate cases. Okay, so let me write it down. Then in part 2, you would get 0 as a point of inflection. And then this one is a minimum point. Whereas for the other one, okay, 80 is a point of inflection. Okay. Any insights that someone would like to share? Yes.
So what is it? Sub in x equals to at the start. That means before you differentiate. Before you differentiate, after you
Sub in, sorry, okay. So now sub in what?
x equals to it
At the start, huh?
So before you do the dy or dx.
So you sub in 2 at the start already, then what?
Then you use that value to differentiate.
Huh? Like that. Then you differentiate this. You differentiate respect to what?
That's why.
Okay.
That's what Aiden told me to do.
No, we cannot. K is a constant. Like that, it's just a constant value. It's not right. Yeah, this one is not differentiable equation at all. Yeah. Okay. Yeah. So cannot do this. Yeah. Okay, because it's dy over dx, right? Alright. You differentiate respect to x, but this one has no x. So really speaking, your dy over dx becomes 0. Alright. Okay, so not right. Okay. Yeah. Alright. Any other opinions or thoughts? Okay. So I'll guess maybe there's an error in the textbook lah. Okay. That they failed to correct. So I don't go through question 10, yeah?
My God.
Okay. Don't go through, ah. Let's look at question 14. Okay. Where K is a non-zero. That we are able to differentiate it. This will be what you get. Am I right that the differentiation is okay? For those that ask about this. Okay, so we do our product rule, right? And then you'll be able to get this if you try to go about doing your factorization. Okay. Then in part 2, given that the curve passes through the point 1, 1, find the coordinates of each stationary point. Okay, so knowing that the curve passes through 1, 1 helps us to determine the value of k. So because when y is equals to 1, x will be equals to 1 as well. So therefore 1 is equals to 1 minus k bracket squared. and 1 minus k is plus minus 1. So k is equals to 0 or 2. But we know that k is a non-zero constant, so we reject k equals to 0 because the question specified that k is a non-zero constant. Okay? So therefore, the function that we are looking at is y equals to x squared times x minus 2 bracket squared. And then our dy over dx, using our answer in part I, would actually be this. Okay? So you're trying to find out the coordinates of the stationary point. That means your dy over dx equals to 0. In other words, 2x equals to 0, x minus 2 equals to 0, or 2x minus 2 equals to 0. So x equals to 0, 2, or 1. And the corresponding y coordinates would be 0, 0, and 1. Therefore, the coordinates of the stationary points are 0, 0, 2, 0, and 1, 1. Okay. Then in part 3, to determine the nature of these stationary points, you could either do your first derivative test or second derivative test. If you want to do second derivative test, there are a few ways to get around it. Okay, with your first derivative itself, you can actually expand the entire thing, then you differentiate from there. That's possible. Otherwise, what you could also do is to just maybe tackle one pair of the brackets. So because we're looking at this, you can just do this first, and then we'll get 2x squared minus 4x. And then you can do your product rule from there. Regarding the second derivative, it really doesn't matter to what extent do you simplify it to. Okay? If you know that your strength or carelessness tends to fall in the factorization process, then I don't recommend that you go ahead and factorize. Just keep it to this, because fundamentally what we want out of the second derivative is to substitute your coordinates over here into it to know whether is it actually positive or negative or not. Okay, so you could just stop over here and then go and figure out at the 3 different points what is that second derivative value. about sketching the graph. Okay, using the points that we have, it will actually help us to visualize how the graph will possibly look like. Spot more. Okay, so we're trying to draw the graph from -1 to 3. We have 3 crucial points, that is 0, 0, so that will be here. 2, 0, somewhere maybe around here. Okay, and 1, 1, okay, around here. Okay, and we know that 0, 0 here is actually minimum. This point here, which is 2, 0, is also a minimum. And this one over here, which is 1, 1, is supposed to be maximum. Okay, so drawing from -1 to 3 itself, okay, will actually allow us to have a graph shape that looks something like that. Okay, how do I know that the curve is like that on the outside ends, right? Okay, it's because I will need to go and substitute in the original graph equation. When x is equals to -1, I will need to realize that this is actually a value of 9. Likewise, when x is equals to 3, okay, my value over here is also 9. Okay, if you don't go and calculate it, you wouldn't know how this would possibly look like. Okay? Then, how is it that I will know that the curve is actually in this manner? It's because minimum point will suggest that you have to curve this way, maximum point will suggest you have to curve this way. Okay, and then minimum, okay. So you will have to go like that. Yes.
So the point 1, 1 is maximum.
What? Sorry, I can't hear you.
The point 1, 1 is maximum, right?
Yes, 1, 1 is maximum.
How come like
Okay, good question. Okay, I wanted to address that as well. So when we talk about maximum, it's usually around a certain area. Okay, we will not dive too much into it. Okay, but this will consider as a maximum point, maximum in that region. Okay, how do I define that region? I will not dive into it. A bit too deep understanding required. Okay, yes. Do we have to write these dotted lines? Okay, not necessary. You could actually just label the coordinates that we put like this one. Or the 9, do I have to label it? Sorry, should I label here or should I label here? I would say yes lah. Okay, since you calculate where the 9 come from is because you sub it into this one, the original curve equation. Ah. Okay, I know that when we learn about maximum and minimum, it is about in totality for the entire function. Okay, we're looking at this maximum and minimum. Okay, but when we're looking at this context, it's actually maximum minimum around a certain boundary, okay, very small range itself. Okay, questions? Alright, if no questions, can you pass your homework to the front? Okay, next I want to finish up our 14.2. Then I think if we have some time to spare, just want to give you a mini art and craft activity. Okay, related to maths of course, right? Hopefully I have time for that. It shouldn't take up about 5 to 10 minutes. Okay. My students have to go off at what, 10 or 10:30? Finish at 10:30, then leave at what time? Price winners, class is a price winner. Your somebody, huh? Diana and Regine. Eh?
Diana and Matthew already went down.
Oh, okay. So you all leave at what time? Can you pass your homework to the front, please? we on the correct page today? Are you submitting your homework to the front or you need more time? Okay, those who may need more time, later on you put it on the table, yeah? Yes. Okay. So last lesson, we have already covered try 7, 8, and 9. Okay. We learned how to use our finding our maximum and minimum into different kind of contexts. I want us to go back to try 6, which was the one that I actually skipped for a while first. Okay. So in this question, you're given that there are two numbers, x and y, and they are related in a way that it fulfills this equation such that when x times y, it must be equals to 20. Okay? And then it also says that there's another number z that is being defined by z equals to x plus y over 5. So in order for us to calculate z, I must actually know what is x but what is y, add them together, and for y need to divide by 5. Okay? In part I want to show that z can actually be rewritten as in terms of x only. So that means that I need to translate my y into in terms of x so that I can substitute inside here and get something like this. Okay. So since we're given that xy is equals to 20, I can make y in terms of x by considering 20 over x. Okay. Then because given that z is equals to x plus y over 5, y will actually be 20 over x and divide by 5 again. Which in other words, we are looking at 20 over x divided by 5, which is the same thing as times 1 over 5. Hence, we can simplify to get x plus 4 over x. Okay? So that will be how we go about showing that z can be written in terms of x. it says that calculate the value of x for which z has a stationary value. Okay, I want to help all of us to understand what this question is trying to ask. Okay, so it's trying to ask us to find out what is this value of x. Okay, and this value of x will lead to z being a stationary value. Okay, we know that when z is a stationary value, that means your dz over dx must be equals to 0. So when I differentiate the z, okay, with respect to x, okay, and equate it to 0, I will be able to find a corresponding value of x, okay, that fulfills this criteria over here. Okay, so that's the very first part of the question. Then in the second part, okay, we want to show that with that number for x itself, it causes z to be a minimum. So we're trying to verify, okay, that z is a minimum, so we can use your second derivative test or your first derivative test, whichever that suits you better. Okay, so first thing, with my z to be equals to x plus 4 over x, I will find out what is dz over dx. If you prefer, you could write it like that before you differentiate. And we find that 1 minus 4 over x squared is our first derivative. So to get z to have a stationary value, your dz over dx must be equals to 0. And we find that x equals to 2 or negative 2. Okay? But we have to reject x equals to negative 2 because question says that x and y are positive numbers. Okay? So there is only one value of x that will result in z being a stationary value. Then we proceed to find out, okay, whether is it going to give us minimum or not. So if you do your second derivative test, so d2z over dx squared, you would be able to get 1. This one is 1 minus 4x for negative 2 minus 4 negative 2x negative 3. Unfortunately, I'm not tall enough. Yes? There's no 1 in what? In the second also, we think. Got distracted by the string. Negative 4, negative 2, x for negative 3. Okay. Then at x equals to 2, your second derivative would be 1. Okay, that is more than 0. So therefore, x equals to 2 makes z a minimum based on your second derivative test. Okay. in your exercise 14.2. We're given this diagram. It is a rectangular enclosure of area A meter square. And it says that it is formed using a wall, the shaded on top, and 36 meters of fencing. Okay. Then the question said that the width is given to be x meters and the length is given to be y meters. In part I, we want to show that y is equals to 36 minus 2x. Okay. So we see that there's a 36 found in the y. That will suggest to us that I have to likely make use of this fact that's given, that there's 36 meters of fencing. Okay. We have to keep in mind that the fencing is only referring to PS, SR, as well as QR. Because reading the question carefully informs us that, okay, this enclosure is made out of wall and fencing, like that. So that means that x plus y plus x will give us 36. Or you could see it as 2x equals to 36, which explains why y equals to 36 minus 2x. Okay. Then in part 2, the question wants us to use the fact that A is equals to xy. Okay, because logically if you look at this, being a rectangle, the area of the rectangle enclosure will definitely be length times breadth, so x times y. Okay, so even if the question didn't tell you this, you need to be able to interpret it out of the diagram that you're given. Okay, then so because we already know that y can be expressed as 36 minus 2x, so upon expanding this, you would naturally get 36x minus 2x squared. Okay? So I would say that part I and part 2 should be slightly manageable, okay, in terms of interpreting from the question. Okay? Then part 3 wants us to find the value of x for which A is a maximum. This should be familiar to us now already. Okay, whereby I need to differentiate your A, okay, with respect to x. Okay, and then find the value of x. That will mean that your dA over dx must be equals to 0. And then to show that it is going to give us a minimum, we can do our second derivative test. Sorry, maximum, not minimum. Not sure whether at the back of your mind, maybe some of you are wondering why is it that I'm even going through this question. Okay. The reason why I want to go through this question is because I want to show you an alternative method. Okay. So this question, I can even solve it, in fact, in Sec 3 without even learning differentiation. Okay. So actually at Sec 3 level, I give you this question, technically you can actually solve it already. Okay. Why? Because, right, I want us to notice that a equals to 36x minus 2x squared is actually a quadratic function. Agree? Okay, quadratic. And quadratic, we already know how to figure out maximum and minimum. Okay, based on what? Based on doing your completing the square. Remember that? Okay, in our first 2 chapters of your set 3, we explored a lot about your quadratic function. Okay, so in this case, right, alternative method. Okay. Given that a equals to 36x minus 2x squared, I could maybe rewrite it as this form, something more familiar to us in a quadratic manner. In doing our completing the square, I must always factorize out any coefficient of x squared first. So in this case, I will factorize out the negative 2, and that will give us x squared minus 18x. Then continue to do my completing the square. Inside here, 18 divided by 2 is 9. Not forgetting to minus away 9 squared. Okay. And then my completed square form will look like this. Negative 2 bracket x minus 9 squared plus 162. Okay. So in case you have forgotten how to do completing the square, I will not dive into the theory, but essentially I have this number based on 18 divided by 2, and I must always remember to minus away the square of that. Okay? And the minus sign actually follows through. Okay? Alright, so from here, how do I actually explain that a is going to be maximum and what is that value of x? How do I even extract out the value of x? I know that because my coefficient of x squared is actually negative, negative in our quadratic function will actually be this shape. Okay, will give us a maximum, right? Okay, so that's the first thing. Next thing is that I can identify the coordinates of the turning point. How? Okay, by looking for the x coordinate over here when this is equals to 0, and the y coordinate is this 162. Remember that? Okay, I see a lot of like smiles. I guess it means that you all don't remember. Okay, so let me just complete this first. I know that the maximum value of a is 162 when x minus 9 squared is equals to 0. That is because from our completed square form, when it is being factorized in this manner, where there's a square itself, I know that whenever a number is being squared, okay, the minimum, okay, the lowest it can go to will be 0. Okay, the highest it can go to is infinite lah, okay, because it is always positive. Okay, so the lowest it can go to being 0, right, okay, will cause this entire part to become 0, okay, and therefore your a will end up becoming 162. That will give us the maximum. Okay, yeah, because even if this one goes to inverse infinity, okay, let's say if I put in 1000, this will be minus 2000. That means we're taking 162 minus away 2000, it goes even lower than 162. So the maximum is being arrived at when this part here is equals to 0. Okay, so that's why we get the maximum value when the the square part, okay, is equals to 0, and that is x equals to 9. Okay, then the maximum value will be 162. But of course, this question did not ask us to find the maximum value of A lah. Okay, but this is what the question really wants us to find. Okay, I'm just sharing with you an alternative. Okay, because whatever that we learned, okay, in your Sec 3 year, okay, when we did our maximum, minimum, and all that. Now that we have done differentiation, by all means, you can do your differentiation method. Okay, nothing wrong with that. I'm just trying to improve or expand the skill sets that we have. Okay? Nico? Yes. Alright, any questions? Okay, so that's all for your chapter 14.2 homework. Okay, I'm not going to insist upon you giving me this kind of method. For homework, please still give me differentiation. Okay? 5 question 5, 8, 9, 11, 13. Page 63 to 65. Alright. As mentioned, okay, I think I'll stop here for today. I don't want to jump into chapter 15. Okay. What I'm giving you is not just a simple art and craft. Okay, I'm giving you a formula mini booklet, so we need to do a little bit of art and craft. Okay, so that you get a very nice booklet that you can keep in your pencil case with all the important AMATS information. Okay, so I always give this to my graduating classes, so I hope that this is useful. Okay, I don't know what other colors you like. Trade amongst yourself. I have green, purple, blue, yellow, and pink. Okay, 14 divided by 5, 8 pieces of each color. Okay, so you all trade amongst yourself. I'm just going to give it random. Okay, sorry. If your friends are not here, just keep for them. Okay, wait for my instructions. I'll teach you how to cut. If you don't have a pair of scissors, you can take a pair here. Please return it to me. Wait. Oh, blue ah. Okay, the reason why I print in color is because in case you put inside your pencil case, make sure when it comes to exam, you remember to take it out.